হ্যালো ফ্রেন্ডস, ফিজিক্স উইথ রয় চ্যানেলে তোমাদের স্বাগত। আজকের ক্লাসে আমরা স্পিড, ভেলোসিটি, অ্যাক্সেলারেশন এবং ডিফারেন্ট কাইনেমেটিক রিলেশনগুলো আমরা দেখব। প্রথমে আমরা স্পিডের কনসেপ্ট শিখে নেব। স্পিড বলতে কি বুঝি? আগের দিন আমরা ডিস্টেন্স পড়েছিলাম। ডিস্টেন্স বলতে আমরা শিখেছিলাম একটা পজিশন এ থেকে বিতে কোনো একটা পার্টিকেল যে পাথ অতিক্রম করে তাকে আমরা ডিস্টেন্স বলেছি, এবং এ থেকে বিতে যাওয়ার জন্য যে পাথেই যাক না কেন সেটাই পার্টিকেলের ডিস্টেন্স হবে। এখন পার্টিকেলটা ইউনিট টাইমে যে ডিস্টেন্স যাবে তাকে আমরা বলবো স্পিড। অর্থাৎ স্পিড মানে ডিস্টেন্স পার ইউনিট টাইম। মনে করা যাক একটা পার্টিকেল এ পজিশন থেকে বি পজিশনে যাচ্ছে এবং এদের মধ্যে ডিস্টেন্স হলো 500 মিটার, টাইম 5 সেকেন্ড নিল। তাহলে আমরা এখান থেকে ইজিলি বলতে পারি স্পিড সমান সমান ডিস্টেন্স ডিভাইডেড বাই টাইম, দ্যাট ইজ ইকুয়াল টু 500 বাই 5, দ্যাট ইজ 100 ইউনিট মিটার পার সেকেন্ড। সো এখান থেকে আমরা স্পিডের ইউনিটটা পেয়ে গেলাম। ইউনিট পেলাম আমরা মিটার পার সেকেন্ড ইন SI, and similar way centimeter per second in CGS, and dimension equal to dimension of length divided by time, that is L by capital T, that is LT inverse. Now এবার আমরা আরেকটা কনসেপ্ট দেখব, that is average speed. সাপোজ একটা পার্টিকেল এ আছে যে T1 টাইমে D1 ডিস্টেন্স যাচ্ছে, T2 টাইমে D2 ডিস্টেন্স যাচ্ছে, T3 টাইমে D3 ডিস্টেন্স যাচ্ছে, অ্যান্ড T4 টাইমে D4। এইভাবে Tn সময়ে পার্টিকেলটা Dn ডিস্টেন্স ট্রাভেল করছে। তার মানে আমরা কি পেলাম? টোটাল ডিস্টেন্স বাই টোটাল টাইম। এই কোয়ান্টিটিটাকে আমরা অ্যাভারেজ স্পিড বলতে পারি। সেটা তাহলে আমরা কি পেলাম? D1 প্লাস D2 প্লাস D3 প্লাস ডট 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 Dn ডিভাইডেড বাই T1 প্লাস T2 প্লাস T3 প্লাস ডট 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 Tn। অতএব SAVG মানে অ্যাভারেজ স্পিড, এটাকে আমরা লিখতে পারি সামেশন I equal to 1 to n di divided by ti। এবার আমরা ভেলোসিটির কনসেপ্ট দেখব। যদি এ একটা পয়েন্ট আর বি একটা পয়েন্ট থাকে এবং এ পয়েন্ট থেকে একটা পার্টিকেলের বি পয়েন্টের ডিসপ্লেসমেন্ট বলতে আমরা বুঝি মিনিমাম distance between A and B, এবং ভেলোসিটি বলতে বুঝি আমরা যদি ইউনিট টাইমে যে ডিসপ্লেসমেন্টটা হবে তাকে আমরা বলবো ভেলোসিটি। অর্থাৎ ভেলোসিটি মিনস ডিসপ্লেসমেন্ট পার ইউনিট টাইম। ডিসপ্লেসমেন্ট পার ইউনিট টাইম। সাপোজ এ পজিশন থেকে একটা পার্টিকেল বি পজিশনে যাচ্ছে এবং এদের ডিসপ্লেসমেন্ট 500 মিটার অ্যান্ড টাইম টেকেন ইজ 5 সেকেন্ড। সো ভেলোসিটি of that particle is 500 divided by 5 is 100 meter per second. As we know, distance is a scalar quantity and displacement is a vector. So, speed is scalar and velocity is a vector quantity. And the unit of velocity is same as speed, that is unit equal to meter per second in SI and centimeter per second in CGS. And also the dimension is same as speed, that is L T inverse. And now we'll learn about average velocity. Average velocity is nothing but it is the displacement divided by total time taken. For an example, suppose a particle moves from A to C and then it moves C to B. Then the displacement is the path of AB, and but the time is A to C say T1 and C to B say T2. Then time is T1 plus T2. So here average velocity equal to path AB by T1 plus T2. But average speed in this case, total distance, that is AC plus BC divided by total time, that is T1 plus T2. And here a particle moving with uniform speed in a circular path. So that distance traveled per unit time, it covers equal area. That means A1 equal to A2 in the same time interval T1, but the direction of velocity changes every point and it is the tangent drawn at that point. So here in this point the velocity's direction, this tangent, this point along this tangent and this point along this tangent. Thus mod V1 equal to mod V2 equal to mod V3, but V1 not equal to V2 not equal to V3 vector, as the direction changes at every point. Now another concept is instantaneous velocity. This is nothing but consider the time interval tends to 0, that is delta t tends to 0. In that case, instantaneous velocity is defined as limit delta t tends to 0 delta x by delta t, that is v instantaneous. Suppose P1, P2, consider the picture. At P1, P2, the time is T1. Similar, for distance Q1, Q2, the distance is T2, where T1 is greater than T2, and if we continue this process and consider the point P, then T tends to 0, and at that point we get the instantaneous velocity is near about 6. Here t is nothing but interval of time. Here is a problem. A car is moving along a straight line, say OP. That means a car is moving O to P in 18 seconds and returns P to Q in 6 seconds. What are the average velocity and average speed of the car in going O to P and O to P and back to Q? So case 1, for O to P, average speed is total distance by total time, that is 360 by 18, that is 20 meter per second, and average velocity is displacement by total time, that is 360 by 18 equal to 20 meter per second. Here you can see average speed equal to average velocity when displacement equal to total distance. But consider case 2, when the car is moving O to P and return P to Q. So at first OP, then PQ. So average speed equal to OP plus PQ divided by total time, that is 360 plus 360 minus 240 divided by 18 plus 6, that is 24, and 360 plus 120, that is 480 divided by 24, that is our 20 meter per second. And now average velocity in case 2 is displacement by total time. So what is the displacement? Displacement is the minimum distance to O2Q. That is, we get from our graph is 240 and total time is 18 plus 6, that is 240 divided by 24, that is 10 meter per second. Here you can see the average speed which we get 20 meter per second, and average velocity we get 10 meter per second. So as displacement is less than distance, we get AVJ velocity not equal to AVJ speed. Now consider this problem. Here the moving particle is given by x equal to a plus bt square, where a is 8.5 meter and b is 2.5 meter, and t is measured in second. What is the velocity at t equal to 0 second and t equal to 2.0 second? And what is the average velocity between t equal to 2 second and t equal to 4 second? Now, given position of moving object x equal to a plus bt square. Now we have to calculate the velocity. We know that instantaneous velocity is dx dt. So we have to derivative with respect to t, this position vector, and what we get is 2bt. As we know that ddt of constant equal to 0 and ddt of t to the power n equal to n t to the power n minus a. We must remember this formula. Now, velocity at t equal to 0 second. What we get? Dx dt at t equal to 0. So put the value of t equal to 0, then we get velocity at t equal to 0 is 0 meter per second. And at t equal to 2 second, dx dt 2b into 2, that is 4b. If we put the value of b, 4 into 2.5, that is 10 meter per second. At t equal to 2 second, x equal to a plus 4b, a 8.5 plus 4 into 2.5, that is we get 8.5 plus 10, that is 18.5 meter. And at t equal to 4 second, we get x 4 second equal to a plus 16b equal to 8.5 plus 16 into 2.5, and we get a result of 48.5 meter. That is the average velocity net displacement by net time. So what we get is 48.5 minus 18.5, 4 minus 2. That is 30 divided by 2 equal to 15 meter per second. Uniform speed. Suppose same time interval say t. The distance covered by any object is d. যদি এই দুটো কন্ডিশন সাইমালটেনিয়াসলি অলওয়েজ সেম থাকে, then we called the speed of the particle is uniform. That means suppose A to B distance is d and B to C the distance is again d. So if a particle moves from A to B, the time taken is t, and similar way B to C the time also taken t, then we say the speed of the particle is uniform. And in case of non-uniform, the situation is like this. Say A to B distance is d and B to C distance is d, but the time taken by the particle for moving A to B is t1 and B to C is t2. That is same distance covered by the particle at different time. That means t1 not equal to t2. And in this case we can say the speed of the particle is non-uniform. And in the similar way we can say uniform velocity যদি displacement at equal time interval same থাকে, then we can say the velocity of the particle is uniform. And in case of non-uniform velocity, that means same distance at different time interval. এবার আমরা অ্যাক্সিলারেশন সম্পর্কে দেখে নেব। অ্যাক্সিলারেশন বলতে আমরা বুঝি velocity change per unit time, v2 minus v1 by t. That means আমাদের ভেলোসিটি ইনক্রিজ অথবা ডিক্রিজ করতে হবে, ইউনিফর্ম ভেলোসিটি হলে হবে না। For uniform velocity acceleration is 0. That means at A point, at B point, for uniform velocity, velocity remains same, that is consider v, then change in velocity is 0, and if time taken is t, then 0 by t is the acceleration, that is 0. So we can say acceleration is nothing but change in velocity per unit time is called acceleration. Let's suppose initial velocity equal to u and final velocity of the object is v, then change in velocity is v minus u, and rate of change in t second is v minus u by t. This is our mathematical form of acceleration and denoted as a. So we can denote a as v minus u by t, where v is the final velocity and u is the initial velocity. As we learned previously that velocity, vector quantity, so acceleration is also a vector quantity, and the unit is unit of velocity, that is meter per second divided by second, equal to meter per second square. It is the SI unit of acceleration. And the dimension is equal to dimension of velocity, that is LT inverse, divided by t, that is we get LT to the power minus 2. The average acceleration suppose a particle follows this path and at point A its velocity is v1 and at point B its velocity be v2, then change in velocity is v2 minus v1. Rate of change, and we consider the time to travel A to B is t. So the rate of change is v2 minus v1 by t, and this is the quantity is called average acceleration. A is v2 minus v1 by t. And what is the direction? If we represent it with vector notation, that is it is v1 and this vector is v2, then this vector denotes v2 minus v1, and we define this quantity as a delta v. Then our average acceleration A is delta v by t. Now we prove the kinematic relations. Suppose a particle moves from A to a point B with an initial velocity equal to u from A, and at B its final velocity equal to v, and it takes to travel A to B in time t second. The rate of change in velocity, we know this is v minus u, final velocity minus initial velocity by time, and this is the quantity is called acceleration A. And if we calculate this, we get at v equal to at plus u, and we can easily write it v equal to at plus u or u plus at, and this relation is known as fast kinematic relation. And if v is given, u is given, and t is given, we can calculate acceleration. And similar way, if one quantity is missing, we can easily calculate from this formula with the help of other quantities the missing quantity. Now we have to prove the second kinetic relation, that is s equal to ut plus half ft square. Suppose a particle moves from A to B and its initial velocity is u and the final velocity is v and the displacement is s. So we can easily say that displacement is average velocity into time taken. So in this case, the average velocity be v plus u by 2. So according to our formula, s equal to v plus u by 2 into t. As we get from first kinematic relations, v equal to u plus at, and we put the value of v in this relation, we get u plus at plus u by 2 into t, and finally we get s equal to ut plus half at square. So we get our second kinematic relation, that is nothing but s equal to ut plus half at square. Now another kinematic relation we have to prove, that is Sn equal to u plus 1 by 2 a into 2n minus 1. That means at n second the displacement is Sn equal to u plus half a into 2n minus 1. How to calculate the nth second? Nth second means nth second minus n minus 1th second. So we have to calculate Sn minus Sn minus 1. As from our formula, we know that Sn equal to ut minus plus half at square, and Sn minus 1 means that is u t minus 1 plus half a t minus 1/3 whole square. And if we calculate and simplify it, we get simply u plus half a into 2n minus 1, and this is the value of Sn, displacement at nth second, and this is our third kinematic relation. And the last kinematic relation we have to prove is v square equal to u square plus 2as. As we know from our previous formula, v equal to u plus at. And if we square it, that is, we get v square equal to u square plus 2at u plus at square. And now if we take common 2a, then we get ut plus half at square. And we know from our second kinetic relation, this is s, so we get v square equal to u square plus 2as, and this is our third kinematic relation.